Lixels, adaptive pixels. Our product is an innovative tracking motion tracking device that displays a portion of a larger image based upon its location on a predetermined background. Here on the left, we have the portion of the picture that is being shown based on the location of the LED board, and on the right, we show where the LED board is in relation to the background. Now, the white picture represents the background and the square represents the LED board, and wherever the LED board is moved, the appropriate portion of the image is shown. To build the touchscreen, we had to get the camera to recognize the LED board and the background. To do so, we developed a software using Python and the OpenCV Python module that would recognize rectangles of a specific color and then give us back the coordinates of the top left-hand corner of each rectangle. The user is also able to utilize this rectangle recognition function to calibrate and define the colors which the computer will use to find the rectangles. During calibration, the user selects various points to track. Then, when the central program runs, the computer gets freed from its camera and then runs it through a filter created during calibration to find the background and the LED board. Then, by finding their position relative to each other, it creates an 8x8 cutout of the 40x40 image that it then sends to the LED board. To display the image on the LED board, we convert the pixels of the image into a string that the board can process. We do this by encoding each pixel as a set of 6 characters. We decided to make a touchscreen because we wanted a project that would be challenging and complex, and we thought it would be something with which we could have a lot of fun in the process. We initially conceived our project to be a simple touchscreen which will recognize input and send and receive information to and from the computer based on where you touch it. However, after researching into how current touchscreens worked, we realized that the process would be prohibitively expensive and entirely out of our technical range. We branched out on different ways to make our basic concept of a touchscreen work, focusing on capacitance fields, which is how traditional touchscreens work, lasers that would be obstructed by an object, and a camera that will track the user's hand. We ultimately decided to employ a camera, and from there, cost efficiency reshaped our goals to the current form. One of the first difficulties that we encountered was getting the LED board to communicate to the computer. The serial communication was a major hassle due to its limitation of the size of data which it could send at once. Another difficulty was programming a reliable form of rectangle recognition that can track both the LED screens and the backdrop. Frequently, our scripts inaccurately detected shapes or patterns entirely in the background and consequently sent the wrong cutout to the board. We solved our first problem by setting in place a variety of counters that would collect the sent data into usable information. Through the system, a reliable stream of information was created. To better detect the LEDs, we created a series of filters that will narrow the possibilities for the computer, therefore boosting the accuracy.
It's on the right track. It's definitely on the right track.
Would you say that as of now it is tracking somewhat accurately?
To some extent. I think maybe if you're like doing like a presentation or something, and you have maybe like a bigger one of these, you could have like a board, and you could like, I think it'd be a cool way to present stuff to get people interested. You could be like, okay, so you could ask them a question and be like, well, here's the answer, and then you could just move it over to the answer. To improve this, the best thing would be just to improve the tracking, because right now it seems to have a little trouble, like sometimes it gets caught on the wire, so it tracks half and half, which is not what it's supposed to do, although sometimes it does it right, so maybe a little more stability, maybe like an algorithm to detect when there's something like a little string or wire.